Hey everyone, another day, another Leetcode problem. So today we're going to be looking at 261, graph valid tree. This is a Leetcode premium problem. So it says if you have a graph of n nodes labeled from 0 to n minus 1, and you're given an integer n and a list of edges where edges of I represents the two nodes between which there is an edge. So these are undirected edges, and so it basically asks us to return true if the given graph can make a valid tree, or false otherwise. So I'm going to explain this here so we can just understand the problem better and see what we're dealing with. So red. All right. So it says the graph has to be a valid tree, and these are the examples that were given in the problem. So if we look at the first one over here, so this is a valid tree, as we can see. And the second one is not a valid tree. And the third one, which I've kind of drawn over here, is not a valid tree either. So let's try to look at these examples to see like a pattern that we're seeing between a valid tree and something that's not a valid tree. So I can see that in the first one, everything is connected, and also I don't have any cycles, right? So that's the problem in the second one. There is a cycle. And in the third one, I see that there are two separate components, right? So it's not a valid tree. So if I have to write this out, I can say there should be no cycles, and also single connected component. So basically, if we can verify that these two cases are true, then we can basically verify that it is a valid tree. And as we know that the main traversal that we do use is either DFS or BFS, so I'm going to go ahead with the DFS over here. And what I'm going to do is in DFS, as we know, we're going to use a visited set to kind of track everything that we've visited. And also we're going to have an adjacency list, which we will prepare in terms of our code. So every node will have its neighbors, and those neighbors will have their neighbors. So we're going to map each node to its neighbors. That will be in our adjacency list over there. So we're going to have a visited. And now one thing in a tree is that if I go to any node, the node has a parent, and because this is undirected, when I'm traversing the neighbors, I will also be accessing the parent itself and its other neighbors, right? So I need to make sure that my DFS actually takes that into consideration. So we can do one thing. We want to traverse the graph, and we want to go from every node to its neighbors, and then we want to keep continuing that, and we want to make sure that we're not going to a node that has already been visited, right? So if I come from 0 to 1, and from 1 I will go back to 0 again when I'm looking at the neighbors, but 0 is fine because it's the parent. But if I was going back to another node which had already been visited, then that would tell me that I have a cycle. So let's just check an example over here. Okay, so let's start from 0. We're going to do a DFS. So I add 0 to my visited. I look at the neighbors of 0, all right? So I'm going to call a DFS here, and the next node would be 1, and its parent would be 0, right? So I could probably start this with like node 0 and a parent as -1, because they've given that the nodes start from 0. We could use that. So once I go to 1, I can write a condition in 1 that 1 has to look at its neighbors. And if the neighbor is a parent itself, it can just continue because that's already visited. So here I'll add 1 to my visited. And then again, from 1, I'll be going to 6. And again, so when I do a DFS of 6, I pass in 1 as the parent. And again, 6 doesn't have any other neighbors, so this returns a true, and 6 is also visited. So from here, I go to 2. 2 will also check its neighbors. 0 is already its parent. Then it goes to 4. So I'll add 2 here. I'll add 4 here. And then, 5 is also visited. Same way over here. 3 is visited. So this is a valid tree, right? And I'm going to then check the length of visited that I have. And if I look at that, it's 4, 5, 6, it's 7. And if we look at the total nodes, our n value here is also 7. So I use that as an extra verification factor because let's say I had another node over here, which was something like a 7, and this was never connected. Then I would have n is equal to 8 nodes, but then my visited set would have only had 7, meaning there were unconnected, disconnected components. Like, yeah. So one more thing is like I'm mentioning over here that we are checking a visited set. So let's see an example where I'd probably come to 5 and 5 had a connection back to 0, right? So then I would look at the neighbors of 5. So 4 is its parent, that's fine. So I would look at the other neighbor, which is 0, and then I would see that 0 is already unvisited, which means that I have encountered a cycle. So yeah, that's basically how the code is gonna look like, and this is it's a pretty simple problem, if you see. So let's just go ahead and code it up so we can. It's probably more intuitive when you see that. So first thing I want is I want to set an adjacency matrix list, sort of hold these node to neighbor pairs. Default dictionary of lists, so I can have for u and v in edges. I have to add this to v's adjacency list as well because these are undirected edges. Append u. Okay, so as we spoke, I will have a visited set. Okay, and now we will have our DFS. So one thing I was passing to the DFS was the node itself and its parent, right? Okay, so every time I do a DFS, one thing I'm gonna do is add it to my visited set. So visited.add node. And yeah, then I'm gonna check and traverse through its neighbors for neighbors and adjacency list of node. So I want to check if it's a parent already, and if it's a parent, then it's fine because it's already been visited. So if neighbor is equal to parent, I can probably just continue. But if there's a neighbor that's not the parent, but it has already been visited, then I know I want to return a false. So if neighbor in visited, okay, and I can return a false directly, or else I want to go ahead and do a DFS, as in I'm going to go and traverse it. So I can do a DFS on the neighbor and pass in the current node because the current node will now be the parent for this neighbor. And if this all returns properly and everything works, then we should be returning true that it is possible to traverse to this node. So what happens is they've given to us that it starts from 0. And what we're given edges, so we'll start traversing from 0 itself. So now what do I want to do? So I can check if not DFS of 0, and then I'll pass in a dummy parent, so -1. If this does not return true, then I want to return false. Right. So if this returns true, then it means that it was able to traverse from 0 to all the connected nodes and there were no cycles, yes. But this doesn't take care of the separate components. Like if there are 2 or 3 separate components, this does not take care of that. One component might return true, but there might be an extra one. So this is where we want to compare that with the number of nodes that we already have. So I want to return true if so length of visited is equal to n, or else false. Okay, so it should be fine. Let's just see if it runs. Okay, this runs properly. So yeah, the time complexity for this would be we're doing a basic DFS, so we're going for every node and then all the edges. So it's v plus e. Just write that out over here. V plus E, and then so my space is adjacency list, yeah, and then I have visited. So again, that's like it's O of V. I could say V plus E because of these edges, but yeah, I'm just going to consider it O of V. But yeah, this is the solution to this problem, and I hope you guys understood. So yeah, happy coding, everyone.